Hello everyone, I'm Xiaogan. Okay, before we officially start writing our JSON in this lesson, we will demonstrate a wrong approach. Although I call this approach wrong, I actually use it too, and many engineers also use it. For example, if we don't consider the latter part for now, and only think about how to write the previous section, we might write it like this. Let's write a public here. So, how do they usually do it? They usually do it like this. Void, then not good. Save. Not a very good save. For this method, we'd better call one over. Do we have some testing methods here? We mainly want to call one. Call one called. That's right. We want to rely on this pipe. Let's step back again. Okay, so let's stick this wire over here. We only need to stick the front part. Okay, then here we need a big cover. Wrap it up. Okay, for example, if we don't have any tools right now, how do we parse it? We parse it manually. Obviously, we've learned about strings, right? We can use an if stream, put info. Then here we can write it like this. They particularly like doing this. That is, some engineers transitioning from other languages. They usually like doing this. And for this part, we better have such a struct. But this struct, since we use it internally, let's define it here. Sensor message. Okay, this struct, we give it an int sensor code. We set it equal to -1. And similarly, this FExperiment message, you don't actually have to use the same name here because it's your own, placed by oneself. So to ensure it is different, we give it an excellent 1. This way you can see it more clearly. Otherwise, you won't be able to tell when it's the same and when it's different. Here we can write it like this. Obviously, we need a curly brace here. Right, a curly brace. Then after the curly brace, we need to add quotation marks. These quotation marks need to be escaped, you see? So this part is really tricky. Then we prepare a placeholder here. As for this placeholder, we use %d. If it's a boolean, you essentially need to write a ternary yourself. Something like that. Okay, then here, we do it like this. We can actually just paste it over. Paste it over. Good. Then here, we need to do it this way. Quotation marks are needed here. This %d is not needed. This needs to be % here. It should be fine like these, because writing it this way means we haven't finished this yet. Okay, write it like this to finish, and in this place, we need to give this one. Okay, this mainly shows that this part hasn't been written yet. But if I think this might cause misunderstanding for you, then we'll write it like this. Like this. Delete this part. Delete this part too. We need to declare a struct. For example, this struct, we call it myInfo, myTempInfo. We negate the texture inside. For example, we give this ucode a value of 998. And then for this UE message, we give it a small steel test. Then next, for the data, we give it 1, 2, 3, 4, 5, 6. For this data, we give it a 1. So once we have the struct, we can just fill this data into it. You probably often do this in Blueprint as well, but I think it's okay. So here we need to switch it to gchar. The second is message. The third is data. The fourth is our seed. Okay. With such information, we don't have a network yet. We'll cover networking later, because we need to finish the spirit part first. Only then will we teach you about HTTP networking. Otherwise, skipping content in between would be very confusing for everyone. So here we save it locally. Then here we have another fail helper. South stream to fail. We wanted to prepare a path. Right, so this part is actually very easy to write. We call it paste, fail paste. We use the past class to get our project serve path. Then we let it concatenate up. We call it not good JSON. Not good JSON. Then we let it end with a suffix form. Okay, here we concatenate this. This is not good JSON. Then next we put this thing in. Look, the first parameter passed is the JSON to save. The second should be this address. We convert this address to chart. When saving, we can actually specify we. It has an auto detection, right? We don't let it, we force it to use UTF-8. We must use UTF-8 for our network transmission. The reason this one is not difficult to use is that it does not contain fail-fail. Let's include it. Okay. Once we enter, we should be good. This part is wrapped by a struct in front, so we have to wrap it like this too. Good. 4小貼符吧. Don't need these folders. Good. This way, we have stored a string locally. After storing it, let's read it back in. When we read it back in, this part is, we can call it initialization. This is the initialization process. We call it charging. Then we need to reverse the charging. You can see. How do we reverse the charging? Well, it's actually very simple. We just bring in what it leaked. So we need to prepare this path. Obviously, we need to prepare a dead node. For this dead node, we give it a bank. Bank not good base. We need to give it an empty child. And then here we put our fail in. Obviously, we don't need to form a number here. We just form it into a word, and that's enough. Let's see what the 3 places he passed are. The first one is the result. The result should be placed first. Then it's very likely this should be placed in cleanup. And if he passes a pointer, let's take a look. Okay, this way it's fine. There's no problem with this. We don't need to worry about the rest after this. Okay, it will read this thing here. So how should we parse this thing? When we talked about strings earlier, actually this is very easy to parse. First of all, you can do it yourself. For example, using find. These bracket marks placed here. Make a judgment. Just split it by these bracket marks. Just split it by these colons. or by quotation marks or other marks. You split them out, then take each field and map them accordingly. Then we won't write it. We won't write this thing. And because this thing is too troublesome, and don't do it this way, because for this kind of simple interface, you can still write it like this. For slightly more complex interfaces, for something like this interface design, how do you cut it, right? Cutting it this way, then it would really be too painful. So we still need to use tools. It's just that this native way of writing is too troublesome. And this is an internet equivalent to technical infrastructure. That is, when writing code, you don't need to completely, that is, if you use Unreal Engine, you don't need to fully develop an Unreal Engine from scratch. Don't reinvent the wheel. So we'll skip this part here. Okay, this is a very primitive, very primitive way of writing. Of course, during this process of layering, it's like we currently have localization. It's fine if we read and write it ourselves. But if you send it over the network, send it to someone else, send it to you, send it to the server, or send it to Unity, and then they receive it. Will it look like this? That's not necessarily the case. So the best method is to compare the two ends. You compare both sides, whether the data you received is the same. And this comparison, you should not compare the encoding. That is, do not compare the final result, because this result may have undergone an excellent transfer. It may have undergone an optimizer transfer. You can see they are different. Directly compare the binary data he obtained. This is the most ruthless method. Okay, then we create a new floater here. This 024, our stage guide. Then we need to create a new level. This level, actually we can just use this level. We will place it here. Okay, Lever accepts. Let me drag an object in here. I really think our place is here. Here, drag this object in. Then we test it in the level blueprint. Okay. We'll stick to the old routine. Good. Here, we call this method. This method is called log_good_save. Good. Let's set a breakpoint. Let's double click to enter. Let's set a breakpoint here. If this breakpoint can't be hit, let's do it ourselves first. If it can't be hit, we need to restart. Sometimes breakpoints drop. Okay. Alright. Now we have it. Let's go check our project. In our demo, inside the save folder, there should be a LotGood base class. And then you'll notice this base class is clearly written wrong. Right. See, we have a typo. This base class has an extra comma here. Very obvious. So we need to fix it. Okay. Let's come back here. And actually, during development, we also use some tools like Postman, are very common in networking. There's an extra comma here. There isn't one here because it has no attributes after it. So you can't have this extra comma. Okay. I'll restart it here. Then set a bright to show you, alright, our break has been hit. You can see we declared an attribute here, right? This level is actually fine already. That's it. This level is okay. Then serialize it here. We'll read it back in. You see, after reading it in, this level actually, this is because it absorbed it, right? Drag it back a bit. Let's push it forward again. This side should still be because of the watermelon. Let's handle it. We've already handled it now. Look at this place. You see, it reads it in, and it's still the same. Let's go check it in our project. This connection. Look at this connection. It's actually like this. Then here we need to party it up to achieve our desired effect, right? Okay. Actually, this method is quite complex, and because in actual development projects, the larger the project team, the more automated tools they will create. Actually, the method we are demonstrating now is essentially the same as your AP. This make st, and then here we'll paste it. We'll paste it here. Let's take a look. Here. We paste it here. Then we put it here. This is essentially the same thing. Essentially the same. You might write it like this. This way is actually not very good, but it can solve the problem. Then you can see our struct here is actually, we wrote a struct ourselves here. Only then can we, in the blueprint code of the framework, if you want to support reflection, write it outside to support reflection. Your blueprint can also remove this struct. So this struct actually, the most advanced approach we have now is to have it generate dynamically and then make it support generics. These are all very, very advanced knowledge. Within UE5, we won't cover them here. You can check out the official shared resources. That is this struct. We don't want to write it in this code. We want it to generate such a struct dynamically, right? And at the same time, we want that when we call this interface here, it returns a generic type, right? A reverse parsing template. A template is that kind of query node. It can be converted into any structure you want, okay? Let me expand on this for everyone. Okay, this first, more native and primitive method. And here, for the demonstrate how to deserialize it, you need to split it yourself and check them one by one. Because these curly braces and square brackets all have special meanings. For example, you find the first curly brace, that means it is at least one object. You find the first left, this square bracket. It means this might be a host. You also need to record the key names of the previous subtitle strings. That is quite troublesome. Okay, that's all for this lesson.